In the intricate network of power distribution, concrete poles stand as silent workhorses, carrying the heavy burden of supporting vital medium voltage lines. But have you ever stopped to wonder about the science that goes into designing these unassuming structures? How do engineers determine the perfect height and diameter of a concrete pole for a specific application? What factors influence the design, and how are they balanced? Join us as we take a deep dive into the fascinating world of concrete power utility pole design for medium voltage applications. Before we continue with this video, if you are new here, then make sure to subscribe so you will be notified whenever we upload a new video. These components play a vital role in preventing electrical current from escaping the conductor and causing damage to the pole or the surrounding environment. The pole must be transported to the construction site and then erected in a precise and accurate manner. This requires specialized equipment and skilled labor to ensure that the pole is stable and secure during and after erection. Overall, designing concrete poles for medium voltage applications is a complex and challenging task that requires a thorough understanding of structural and electrical engineering principles. The strength and durability of the pole depend on the quality of the concrete mix and the reinforcing steel used. Factors such as the erection procedure, the use of formwork, and the placement of reinforcing steel must be considered to ensure that the poles are constructed properly. This includes regular inspections, repairs, and strengthening measures to extend the lifespan of the poles and reduce maintenance costs. They must also stay up to date with the latest design codes and standards to ensure that their designs are robust and resilient. Additionally, engineers should collaborate closely with other stakeholders, such as contractors and suppliers, to ensure that the design is feasible and cost-effective. This includes the conductor size, the type of support structure, the soil type, and the environmental conditions, such as wind speed and seismic activity. This includes the weight of the conductor, the sag in the conductor due to its own weight, and the effects of wind, ice, and seismic activity. This includes selecting the right concrete mix design and the reinforcing steel for the pole. The materials must be selected based on the load calculations and the design constraints, and they must meet the necessary strength and durability requirements. The load calculations must be done according to industry standards and codes to ensure that the pole is safe and reliable. Once all the necessary information is gathered, the preliminary design of the pole can be developed. The drawings must be detailed and accurate to ensure that the pole is constructed properly. They should include the concrete mix design, reinforcing details, foundation details, and any other relevant information. Remember that each stage is crucial in ensuring that the final product meets the necessary standards and can withstand the loads it will be subjected to throughout its lifetime. This involves determining the required height and diameter of the pole based on the loads and constraints. The procedures must be safe and effective to ensure that the pole is stable and secure once it is erected. The mix design involves selecting the right proportions of cement, aggregates, and water, as well as any necessary additives or admixtures. The concrete mix must be strong enough to withstand the loads that the pole will be subjected to, as well as any environmental factors such as freeze-thaw cycles. Also, don't forget to subscribe so you won't miss any future videos. We appreciate your support and look forward to bringing you more informative content in the future. Overall, designing concrete poles for medium voltage applications is a challenging but rewarding task. The reinforcing details include the size, shape, and placement of the steel bars or mesh within the pole. The steel must be placed correctly to ensure that it can effectively transfer the loads to the concrete and prevent the pole from cracking or failing. By understanding the fundamental principles and best practices, electrical engineers and technicians can play a vital role in ensuring the reliability and efficiency of the power distribution system. The foundation design involves determining the required depth of the footing and the amount of reinforcement needed to prevent the pole from collapsing. Engineers must select the appropriate materials and ensure that they meet the necessary strength and durability requirements. By following best practices and working with experienced professionals, utility companies can ensure that their poles are safe, reliable, and efficient for many years to come. Therefore, engineers must ensure that these components are properly installed and maintained to ensure the safety and reliability of the power distribution system. And if you find our videos helpful, please like and share them as well. These loads can include the weight of the conductor, the sag in the conductor due to its own weight, and the effects of wind, ice, and seismic activity. Engineers must calculate these loads and design the poles accordingly to ensure that they can withstand the maximum anticipated loads without failing. The design of these poles involves a complex interplay of structural and electrical considerations. We will cover factors such as load calculations, material selection, construction methods, and maintenance considerations. This involves considering various factors such as the conductor size, the type of support structure, and the environmental conditions. For example, areas with high winds or heavy snowfall require taller and stronger poles to withstand the additional loading. Once the dimensions of the pole are determined, the next step is to design the base of the pole. The base is an important component of the pole structure, as it must be strong enough to resist overturning moments and provide a secure foundation for the pole. This involves calculating the required depth of the footing and the amount of reinforcement needed to prevent the pole from collapsing. Additionally, the base of the pole must be properly grounded to prevent the buildup of electrical charges that could lead to a fault or an explosion. In fact, the design of concrete poles for medium voltage applications is a specialized field that requires a unique set of skills and expertise. Electrical engineers and technicians who are involved in the design, construction, and maintenance of medium voltage infrastructure must have a thorough understanding of the fundamental principles that govern the behavior of concrete poles under various loading conditions. Utility poles are an essential part of the power distribution system. They provide a strong and durable structure to support medium voltage lines. The first step in designing a concrete pole is to determine the required height and diameter of the pole. Another crucial aspect of concrete pole design is the consideration of safety features such as insulators, conductors, and lightning protection. It is also important to consider the transportation and handling of the pole during construction. Now let's discuss some key aspects of concrete power utility pole design for medium voltage applications. Load calculations. One of the primary factors to consider in the design of concrete poles is the loads they will be subjected to throughout their lifetime. Material selection. The materials used in the construction of concrete poles are another critical aspect of the design process. Construction methods. The way in which the concrete poles are constructed can also impact their strength and stability. Maintenance considerations. Finally, engineers must also consider the maintenance requirements of the concrete poles throughout their lifetime. By considering these factors, electrical engineers and technicians can design safe, reliable, and efficient concrete poles that support medium voltage infrastructure. To fully understand how concrete poles are designed for medium voltage applications, let's analyze the different stages involved in the process. Stage 1. Preliminary design. The first stage of the design process involves gathering all the necessary information to determine the loads and constraints of the project. Stage 2. Load calculations. The next stage involves performing detailed load calculations to determine the maximum loads that the pole will be subjected to throughout its lifetime. Stage 3. Material selection. Once the loads have been determined, the next step is to select the appropriate materials for the pole. Stage 4. Concrete mix design. The concrete mix design is an important aspect of the pole design process as it determines the strength and durability of the pole. Stage 5. Reinforcement detailing. The reinforcing steel is an important component of the pole as it provides the necessary tensile strength to resist the loads. Stage 6. Foundation design. The foundation of the pole is also an important aspect of the design process as it must be strong enough to support the pole and resist any overturning moments. Stage 7. Construction drawings. Once the design is finalized, the next step is to prepare the construction drawings for the pole. Stage 8. Erection procedures. The erection procedures are an important part of the construction process as they determine how the pole is lifted and placed in the ground. By following these stages, electrical engineers and technicians can design and construct concrete poles that are safe, reliable, and efficient for medium voltage applications. Thank you for watching this video. If you found it helpful, please remember to leave a thumbs up as it helps us to reach more people with valuable content like this.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.